this chapter, we're going to find that we have three different ways to solve systems of equations. One of which we just did, it was graphing. The next one is going to be a system of equations algebraically. So, first method we're going to do is called substitution. Okay, so the first method we already did was graphing. So I have good news for you. We're not going to graph for a little bit. Bad news, it's going to come back. If you like the graph, that's good. If you know how to graph, that's great, because we're going to have to use it later on. So substitution is what we're going to use in this lesson here, and then the last one that you're going to use is called elimination. Okay. So what you want to do is start thinking about, what does substitution mean? Okay, so what's the meaning of substitute? Okay. And then how does it apply to math? Well, what a lot of you think about when we say substitute, especially since you're in school right now, you think about a substitute teacher. So usually we think of something as replacing. Okay. Now, how does this apply to math? Well, when I replace things in math, they have to be exactly the same. And what we mean by exactly the same is equal. Okay, so let's say that if I was going to be out for a day and there was going to be a substitute in for me. Now, according to the school, that's equal. Okay, but you and I both know, because you hold me in such high regard, that we would not be equal, right? A substitute would just be filling in for the day until I was back. But that's exactly what we're talking about. So substitute meaning to replace, and since we're talking about this and applying it to math, it must be exactly equal. Right, so let's use that idea and figure out how to solve. Okay. Now we have a couple that are set up really nice for you to get started. And what I mean by really nice is, take a look at this right here. X is equal to 4y. Well, that's super duper, because I can now replace x with 4y. So I'm going to have 4 times 4y minus a y equals 75. Well, 4 times 4 is 16. 16y minus a y equals 75. So 16y minus, if you need to see that, 1y is 15y. 15y equals 75, and divide by 15. So y equals, alright, doing our division, we're going to find out that y equals 5. So we know that y equals 5. Now what you have to remember is, when we did graphing, all our answers were ordered pairs, because not only did I have to find x, but I also had to find y. And with graphing, that's really easy, because we're finding an ordered pair. What you have to remember here is, now I need to usually go back to where I started, plug this in. So x is going to be equal to 4y. In place of y, we're going to substitute 5, so x equals 20. So the ordered pair would be 20 and then 5. So our final answer is the ordered pair 25. Alright, in our second example here, what we want to point out is the same thing, is these are starting off pretty elementary, because one of the variables is already solved for, because that's going to be our first step when it's not done for us. So y is equal to 3x. So where I have y, I can substitute 3x. So y can be replaced, right? That's the word we used, replaced. Keyword today, substitute. So x plus 2 times, in place of y, I'm going to substitute 3x equals negative 21. So I have x plus, distribute here, 2 times 3x is 6x equals 21. 7x equals 21. Divide by 7, x equals 3. And remember again, I do not have the whole thing done yet until I have x and y. So the nice thing about substitution is, I'm going to go back where I started. Y is equal to 3x. Y is equal to, I can substitute for x the value 3. So y equals 3 times 3 is 9. So the ordered pair 3, 9 is my final answer. Remember, a system of equations, I have at least 2 equations, in this case linear equations, and I want to find a point that they intersect. So if I was to graph these, they would cross at 3, 9 on the x and y coordinate, or the coordinate plane. Alright, so this one isn't as easy for you, because we don't have either x or y already solved for. So let's go ahead and list some steps here, and they're going to be very, very general. Okay, so don't get frustrated. But the first thing I want to do is solve Well, let's not even use the word solve, right? Because I'm not actually solving anything yet. What do you want to do? How do you want to say get one of the variables by itself? Okay. Well, let's say it that way. Get x or y alone. Okay, so in any equation. So what I'm looking at is the 7x, this 2y. Can I get either one of these alone real easy? I don't think so, but if I have 8y and 4x, I sure can do that. And then the question becomes, do I divide by 4 or divide by 8? Because remember my step, it says get x or y alone. It doesn't matter which one. I want to do this the easiest way possible. Well, if I divide by 8, this becomes 1/2. If I divide by 4, this becomes 2. That's exactly what I want to do. Okay. So x equals 2y. So the first thing I want to do is get one variable by itself. So get x or y, so one of the variables alone. The next thing we're going to do is the key word today. Substitute. Okay, so if I substitute, and it should be intuitive, but I don't know why, I need to add this into the other equation. Okay, substitute into the other equation. So now I have to use 7. I had x, so in place of this x, I'm going to put 2y plus 2y equals -8. So now we can solve. So that's 14y plus 2y equals -8. I got 16y equals -8. Divide by 16, divide by 16. Now I don't have a choice. That's the division I have to do. So y is equal to -1/2. So step 3 is to solve for x or y. And we have to say x or y because I could have solved this the other way. So right now I have y solved for. Step number 4. Remember, I'm at this point where I know that what y is. So what I'm going to do, I'm going to take this value and replace it back into this equation. Remember the other word for replace, our keyword today is substitute. So we're going to substitute, and step 5 is solve for the second variable. Alright, so I have x plus, x equals, let's fix that real quick, x equals 2y. So just brought that down from up here. I know y equals -1/2. So x equals 2 times -1/2. So what's half of 2 is 1, and negative times positive is negative. So x equals -1. So the ordered pair is -1 and -1/2. So these two lines would cross on the coordinate plane at -1 and -1/2. Alright, back to something a little bit easier. Y is already solved for. I have a little more stuff going on here, so that's why I want to try and take a step back here. So I got 6x minus 2 in place of this y. We're going to put in 3x plus 2. 3x plus 2 equals -4. Let's distribute. Let's be very careful. Distribute -2. So this is minus 6x minus 4 equals -4. Well, 6x minus 6x is nothing. So -4 equals -4. So is this true or false? Is -4 the same thing as -4? It's true. That means we have all real numbers. Remember the sign we're using for that? All real numbers. Okay. If it became a statement that was false, then there would be no solution. So we kind of cover both of those at the same time. So it does come out to be true. Alright, now I'm not sure why, but for some reason this problem is always a stumper. And I'm going to try and help you so that that doesn't become a stumper for you. First thing we'll do is kind of read through the problem and see what's going on. So Americans spend more time online than they spend reading daily newspapers. Well, that's probably true by now. If X represents the number of years since 1993 and Y represents the average number of hours per person per year, the following system represents the situation. So reading daily newspapers. Well, if we're spending more time online, then yeah, this number's going down. So we see that right there. Reading online, going way up. Look at that slope, 14.4. Now, what we have to do is we have to remember this basic concept. Remember, substitution means the same. Well, I think we would all agree that y is the same thing as y. So if I say y equals y, that means I can take and replace these other equations and plug them in. So negative 2.8x plus 170 equals 14.4x plus 2. Okay, so even though it's set up for very nice graphing, right, slope-intercept form for both of these guys, these aren't the best numbers to deal with. Do we want a y-intercept of 170? Probably not. So here we get a better, I don't know if it's a better method. It's a better method for this problem, that's for sure. All right, we want to get all the x's on one side and all the y, or all the constants on the other. So here I'd probably add 2.8x and subtract 2. So I got 168 equals 17.2x. Well, I think you can see by my answer that x is going to come out to 9.77, so let's call it 9.8. 9.8. And remember, x represents the number of years since 1993. Well, that doesn't even reach 2000. Well, it goes to 2003, almost. So we're kind of having a little bit of an old problem here since it's now 2012 when I'm making this video. Alright, so that's the number of years it would take for the online reading to overtake the newspapers. So we've already passed that point. So we're not exactly using a prediction anymore, but we can see how well it works out. Y represents the average number of hours per person per year. Well, let's go ahead and throw that in there. I can solve it into either one. So y equals 14.4. In place of x, we're using 9.8 plus 2. All right, so we're going to do 14.4 times 9.8. We're using our rounded answer here. And that's going to give us 141.12. And don't forget to add the 2. I'm not going to do that. So 143.12 equals y. So 10 years, almost 10 years, we're going to pass that, and the average number of hours per person is going to be 143 per year. Okay, so do you read the newspaper or read online news for 143 hours? I don't know. Alright, so looking at our steps again, our next problem, so I can divide everything. I can divide 6 by 2, but it's going to be 3 halves, that sort of thing. So when I see a problem that's 1x and 1y, this is the equation that I'm probably going to go after to get one of the variables alone. And it doesn't matter which one. So if I just want to take and subtract y, x equals negative y minus 12. So now I have something to work with. Step 1's done. I solve for one of the variables. And you could do this problem the same way by subtracting x if you wanted to. We're going to substitute into the other equation. So 2, in place of x, I'm putting negative y minus 12 minus 3y equals 6. Alright, make sure we distribute, we get negative 24. And the next thing we want to take care of is negative 5y minus 24 equals 6. Let's add that 24 over. Well, hello there, 24. Negative 5y equals 30. Divide by that negative 5. So y equals negative 6. So we want to make sure that we have our goal in mind. Our goal was to get all one variable into the equation. So I can solve for y in this case. And then I have to go back and solve for the second one. So I can always go back to the equation that I created in this point. So x equals negative, and I'm going to treat that as negative 1 times negative 6 minus 12. When I see it this way, I won't make a mistake. Now I know that this is 6 minus 12. So x equals negative 6. So the ordered pair, negative 6, negative 6. So that worked out nice, because I can't get this one backwards because they're both negative 6. take a quick look at the problem. X, 3x, 5y, negative 2y. Okay, and it should start to jump out at you a little bit that this 1x is going to be the easiest thing to get alone. If I just subtract 5y, boom, done. X equals negative 5y minus 3. Now I have something to work with. I know exactly what x is equal to, so I can replace this one with what x is equal to, right? Replace, substitute, same thing. So 3 times negative 5y minus 3 minus 2y equals 8. Distribute, distribute. Negative 15y minus 9 minus 2y equals 8. 15, 2, both negative, so negative 17y minus 9 equals 8. Well, hello there, Mr. 9. Negative 17y equals positive 17, so y must be negative 1. Well, y is negative 1. We're going back up to this original equation that we made here. X equals negative 5 times negative 1 minus 3. So we have 5 minus 3, which is 2. Now, you'll have some people that say, well, always go with an original, because that way you know that you didn't make an error in the work that you did and then have it carry over. So let's just double check that way. X plus 5 times negative 1 equals negative 3. Well, that's negative 5 equals negative 3 plus x, and add 5. Well, that's 2 again. So x equals 2. Alright, so if you're kind of unsure, if you want to just double check with something else, you can always go back to any of the originals and plug it in. I like to go to this one because I feel like at this point we're being pretty safe about what we're doing. And in class we can check with each other as we go. So x is 2. Ooh, I don't need that. Ordered pair time. Here we go. 2 and negative 1. So again, that would be the point that they share if we were to graph it. Alright, looks like we got one more, and then there should be one in your packet I want you to try for when you come in, and that's going to be our launching point. So I have 4x, 3y, not happening, 2x, 1y, but this one is negative. Yeah, let's still use that. Okay, so I'm going to do this in 2 steps, so minus 2x and minus 2x, negative y equals negative 2x plus 7, and either multiply or divide by the negative. I'm going to use multiplication. So that would be positive y equals positive 2x minus 7. Now I have an equation to work with. And we've also practiced taking a standard form equation and putting it into slope-intercept form, just like we did in Chapter 5. So all these skills, they're just going to keep coming back and back. So the better you get at them, the easier your life is going to be for the rest of this course. So I have 4x plus 3 in place of y. Y is equal to 2x minus 7. Alright, let's plug it in. 2x minus 7 equals 4. Distribute 4x plus 6x minus 21 equals 4. Let's combine some like terms. (10x minus 21 equals 4). Plus 21 plus 21, 10x equals 25, and divide by 10. Okay, x equals 2.5. And again, we can go to an original, or you can go to the work that you did if you feel pretty confident about what you're doing. We can do both again if you'd like, but I'm going to go right here. So I get y equals 2 times 2.5 minus 7. So if you have $2.50 twice, you've got $5. And with that, you can buy a foot-long sub. You know, they don't tell you about the tax, but, you know, whatever. Y equals negative 2. So we have 2.5 and negative 2 as the ordered pair. So this is the point in which they would cross. Now what you have to remember is to have something like 2.5, that's hard to identify on the graph. So again, we're starting to see, you know what, this is a pretty nice method, and maybe I should spend some time learning it. It's going to save you some work later, unless you're required to graph it. Alright, try out this exit pass. Okay, we want to see how you do with that. And I'll show you a couple different methods and some different things we can do with it as we go through this chapter. It looks like a basic problem, but we can have a lot of fun with it. Alright, some other things we're going to do in class is we're going to explain why you might choose substitution rather than graphing. So what things do we talk about in the video about why you'd want to use this? Describe the graphs of two equations if the solution of the system equations yields the equation 4 equals 2. So is that true or false? And what does that mean? So you can flip back and see we had a problem where it came out to be true, and what did it mean? And we're going to definitely do these in class to get started.